In order to do a carbon overwrapped rotor, you've got to wind it at extremely high tension. I mean, this is really an amazing work of engineering.
The real reason Tesla developed the Plaid motor. What makes Tesla Model S Plaid the most powerful production vehicle ever on the road in terms of acceleration? Actually, there are a lot of various components working together, but the Plaid's 3 extremely unique electric motors and battery pack are at its core. Even with a sophisticated design like the Plaid, learning the fundamentals of what happens inside a Tesla motor is actually not that tough. Therefore, let's begin. Nikola Tesla was an engineer and inventor who worked with electricity and magnetism in the late 1800s and early 1900s. Nikola's invention of the induction motor, an alternating current motor powered by electromagnetic induction, is the real reason that Tesla, the automobile manufacturer, adopted his name. The stator and rotor, 2 essential parts of the induction motor, are located inside. The motor's inner center, the rotor, spins while the stator, which is still, is the outside ring. The rotor moves around. A rotor in this application is the iron core surrounded by rows of permanent magnets that run lengthwise. For the sake of simplicity, let's say there are 4 rows and these magnets are evenly spaced around the ring, top, bottom, left, and right. Each quarter of the ring has an alternating pole, so they go north, and south as you go around. Each coil of copper wire in the stator's tube of electromagnets, which surrounds the entire ring and runs lengthwise, functions as a separate electromagnet that can be turned on and off and have its polarity reversed by simply adjusting the power fed into each coil. Therefore, by enclosing the rotor inside the stator, we have a permanent magnet inside of an electromagnet, creating a magnet within a magnet. Now, whenever you place 2 magnets close to one another, a natural push and pull will occur, with the opposite poles pulling toward one another and the like poles pushing apart. The rotation will, however, come to a stop once the first alignment is finished. To keep the stator magnets' north and south poles rotating around the outer ring, all we need to do is move them back and forth continuously. Again, we accomplish this by regulating the flow of electrons through the wire coil. As a result, when the south pole of the stator rotates in a circle, it pulls the north pole of the rotor along with it. Conversely, when the south pole of the stator rotates in the opposite position, it pushes the south pole of the rotor. The rotor will spin due to this constant push-pull action, and the faster the magnetic field is moved around the stator, the faster the rotor will spin. This is what the Tesla T logo represents. It is a cross-section of an electric motor with the sharp T shape representing a slice of the rotor and the top curving line representing the stator wing. If it were that simple, everyone would do it, which would also mean that the Rivian R1 with 4 motors would be the fastest car in the world, but it isn't. There are other factors at play in making this car so fast. Since Tesla specifies the Plaid design as having a carbon rotor sleeve on the product page, we are aware that this is a distinguishing feature, and Elon made a lot of mention of this carbon sleeve technology at the Plaid launch ceremony held at Tesla HQ in 2021. This is the first rotor that Elon is aware of that uses carbon composite instead of the typical steel sleeve around the outside. The rotor is actually wrapped in a very tight layer of carbon fiber threads. If you're more familiar with a fishing reel or a bobbin being filled with thread, that would be a good analogy for the rotor. Additionally, epoxy is soaked into the carbon fiber thread to cause it to form a solid mass. Elon claims that Tesla performs this wrapping process under extreme tension. They actually had to build a new machine that could wrap the threads tightly enough. And the reason for this is because the carbon fiber actually has to be compressing the rotor to prevent a separation from ever occurring when the rotor contracts. This is because the rotor material will shrink at low temperatures, but the carbon fiber will not. So, just as the rotor can contract, it can also expand, and not just at high temperatures or under extreme pressure, like when it's rotating at 20,000 RPM. Elon hinted that if the wrap wasn't holding the rotor together, the centrifugal force would actually lead it to extend outwards and would potentially fly apart. But because we want to keep the gap between the rotor and the stator as narrow as technically possible, we don't want the rotor to expand. We are aware that the force of the attraction and repulsion between 2 magnets increases with their proximity. The rotor is spun by that force, which is at its greatest when the rotor is as close to the stator as it can be. But if we know that the rotor would enlarge at maximum power, we'll need to widen the space between the two to consider that growth. We can keep that gap much smaller if the carbon fiber wrap is keeping the rotor from growing, though. Microns are being discussed. Although this is a minuscule measurement, it is important for maximizing the performance of your motor. This enables the Plaid to maintain maximum power over its range. All prior Model S motors have a power curve that shows that while they start quite powerful, they actually lose power as the vehicle's speed rises. This is not what the Plaid does. The Plaid's rotor permanent magnets are substantially more potent than the typical electric car motor and even outperform Tesla's regular motor in terms of strength. The magnets within the Plaid rotor are more than a third more powerful than the rear motor of a dual-motor Model Y or Model 3 and are almost twice as strong as the magnets inside the rotor of a Mustang Mach-E.